Here we will have the formula for improved Euler method. So for the Euler method and the improved version, we are trying to approximate the solution of the initial value problem. Y prime equal to f xy, y at x0 equal to y0. We approximate the solution of this initial value problem. So for the Euler's methods, the actual version Euler methods, what we do is as follows. Assume that this is the solution curve, the exact solution curve. So the points on this curve will satisfy this system, and we know that x0, y0 is on this curve. Say this point, x0, y0, and we don't know how to solve the exact solution, so we approximate that. In the Euler's version, we approximate that by this tangent line. So near this point, the points on the tangent line will be used to approximate the points on the curve. So this tangent line, let's say L passing through x0, y0. So this point belongs to L. And the slope of L, slope of the tangent line, of the exact solution curve, say this is y, of the curve y, this one will be y prime definition. So derivative here is at the point x0, y0 will give us the slope of the tangent line of this curve at this point. But the initial value problem says that y prime is f x y. So y prime at x0, y0 is f at x0, y0. So this line L can be written as the equation. L has the equation y minus y0 equal to slope. The slope is f x0, y0 times x minus x0. So the equation of the line L is y equal to y0 plus f x0, y0 times x minus x0. And because now we want to approximate the points on the curve by the points on the tangent line, so our first point say x1, y1. So the points on this tangent line will be used to approximate this point. x1, y1 is the first point, we approximate that. So x1 will be x0 plus 8. 8 is a step size. y1, x1, y1 belong to this tangent line. So the coordinates satisfy the equation of the tangent line. So y1 is y0, f x0, y0 times x minus x0. X minus x0 equal to 8. So y1, y0, f x0, y0 times 8. So this is a formula for the Euler's methods for x1, y1, and you do the same thing for, say, coordinates xn plus 1, yn plus 1. So xn plus 1 equal to xn plus the step size 8, yn plus 1, yn, slope is fxn, yn times 8. Here's the formulas of the Euler's methods. Here for all n greater than or equal to 0. This is the Euler's method. Now they want to improve that. The improved version would be as follows. The improved Euler method. The idea for improved Euler method is that they say that, hey, we use the slope at the points xn, yn here. And when you move h units, you have xn plus 1 and then yn plus 1. And the idea is, why don't we use the slope at this point? Because we do know what is the exact slope at this point given by this system. Right? For xn plus 1, yn plus 1, we do know what is the slope y prime at that point. So the idea is, we know the slope at xn, yn. Now, using the prediction, you move h units, you have xn plus 1. Say we have this yn plus 1. They want to use the slope at this point too. And then they take the average. So that's the idea of the improved Euler methods. So the first step, we call it the predictor. So what we do is that we let still xn plus 1 is xn plus the step size h. Now yn plus 1, we don't finish with the yn plus 1, so I write yn tilde is yn. So exactly this formula. I will just copy that yn plus the slope xn yn times 8. We use the Euler methods here for the predictor. We are here. Now second step, we will use the average of this slope at this point and the slope at this point. And that step we call it the corrector. Now we compute the slope as xn plus 1, yn plus 1, y tilde n plus 1. Slope at xn plus 1, y tilde n plus 1. So this is the slope on the other end here. Yes, I write y tilde n plus 1. And then I want to take this slope, with this slope do the average. Compute the average of the two. Slope, average of the slope is the one on the initial one and then plus the one on the end. Take the slope here plus slope here divided by 2. F xn yn plus f xn plus 1 y tilde n plus 1 divided by 2. So this is the average. And now use this slope to write down the equation of yn plus 1. Yn plus 1 equal to, so we have exactly this formula. But we use the average slope. Yn is yn plus 1 is yn plus average of the slope plus this term times 8. This is the corrector. So this formula is the corrector. The first formula is a predictor. This one is a predictor. We compute xn plus 1, yn plus 1. So this one will be the points we predict, or we approximate the points on the actual solution curve. So this is the formulas for the improved Euler methods. Improved Euler methods. So the question is this really an improved version? And the answer is yes. The error, we are talking about the cumulative error. If we only use the Euler methods version, the errors when we use the Euler methods y actual minus y approximate. This one absolute value of I say y actual y at xn. This is the actual one minus the approximated version yn, and they show that this one is at most so less than equal to c times h, a constant times the step size. However, the improved version, improved Euler methods, we show that for improved Euler methods, the errors, cumulative errors, is bounded from above by c times h squared. So you see that is less than or equal to some constant times h squared. When the step size h is small enough, this h squared will be much smaller than h. So that's why the improved Euler methods is actually an improved version of the Euler methods. The errors is much smaller.